Microsoft information security expert Kirill Bogdanov will be speaking next. Hello, colleagues. Today we are going to talk about a new solution in the Microsoft portfolio, Azure Defender for IoT. My name is Kirill Bogdanov. So we'll talk about what makes the protection of technology networks different from the IT infrastructure. We'll talk about Defender for IT, talk about deployment options, run a demo, and talk about UI, and also share the insights of the team that used this solution almost off the cuff during the standoff, what they think about this experience. So the presentation will be available at the link shown in the bottom right corner of the screen. So you can just open it up and view it in the shape and form that you prefer without necessarily following my flipping the slides. My name is Kirill Bogdanov. I'm security expert at Microsoft Russia. And over the past 10 years, I've been helping large enterprise customers to provide safe and secure usage of Microsoft Cloud environments and services. So what makes protecting OT different from protecting IT? Gartner's definition of operational technologies, security as practices and technology used to protect people, assets, and information involved in the monitoring and/or control of physical devices, processes, and events. So largely speaking, it's everything around us: production, energy, water management, smart buildings, chemical, pharmaceutical production, oil and gas. So everything that involves the control processes and that need to be ensured. So what's the difference between IT and OT security? If in IT we're talking about the big focus on confidentiality and privacy of data, in OT the focus is on safety and availability, even though the cornerstone of any security activity is the security of a human. In OT, it's ultimately important, because if a service goes down, that may lead to a catastrophe. Also, IT networks are built on standard protocols and devices using a limited, finite number of operating systems, so things that have a long history of evolution. And on the other hand, IT security as a field has been existing for more than 20 years. So all the previous work serve as a foundation to provide security there. In technology networks, operational networks, the situation is absolutely different. Most protocols are proprietary. There's no complete information of what's happening there. So you need to reverse engineer a protocol to understand what's involved in it. Also, quite often, the users of these solutions, especially if they are large industrial manufacturers or some specialized users, they can create and extend their versions of the protocol, on the one hand, to protect information create IP and also to provide security obscurity. Also, quite often, it does not imply that these protocols will interact with other agents. And obsolete operating systems that may be encountered in such networks running on controllers or other devices such as Windows XP, Windows NT, legacy operating systems that have not been designed to mitigate the current threats. Another difference. Today's IT networks have a large degree of connectivity with the internet. You can see what is happening with the infrastructure of many enterprises as people need to switch to working from home. Microsoft promotes remote management of cloud services and the mass use of cloud technologies and services to automate business processes has become an integral part of the IT world. So, as a rule, new solutions are usually developed based on the understanding that they'll be connected to the net, which is absolutely not the case with operational networks. They're quite often isolated from external networks, in many cases physically, the so-called air-gap networks. Again, because there are no benefits seen in that connectivity, and on the other hand, just as an attempt to avoid the risks involved in such connectivity. So what will the integration between these two security domains offer? If we go through the existing approach, that is, there is connectivity and more than 20 years of development based on the focus on mitigation. In IT, in OT, we don't see even a basic understanding of the risks. That is, such systems are usually developed by very good engineers who know the technology, who know the process, but have sometimes very poor understanding of technologies and threats that are available in the IT stack. At the same time, the IoT risks and OT-related risks affect business directly. So the direct financial losses, like for instance, over the past year, there are a lot of factories and manufacturing facilities that have become victims of ransomware. And it's about theft of intellectual property, again using operational networks, where attackers are connected to IT devices gain access to the intellectual properties. Again, you can recall Sony and Target attacks. They were following this scenario. And direct physical safety of people, according to researchers. The malicious code exploiting the vulnerabilities of control systems, targeting hundreds of thousands of devices in hundreds of countries every day, trying to exploit the known vulnerabilities. Let's at least recall an attack on a hotel where the guests stayed locked in their rooms, and the attackers were requiring a ransom for deblock the physical access control system. All these needs, the drawback of all of these solutions in this area pushed Microsoft to develop the Azure Defender for IoT solution. Let me say that Microsoft decided not to try and reinvent the wheel, and just like it quite often happened in the previous years, we acquired a company that was a leader in this area. I'm talking about the CyberX company, and we integrated their solution in our own stack. Now, public preview of the new technologies available. The current name is Azure Defender for IoT. Nevertheless, we tried to keep all the best that our colleagues had developed without considerable changes to the core part. So what does this solution do? It's a solution to manage security of unmanageable agent-free devices. If you recall, controllers and devices that operate in such networks does not imply connecting a device that will be monitored. More than that, active monitoring or scanning is deemed to be impossible because it may disrupt the operation of such devices. So the first thing that this solution does is the detection of IoT and OT assets. What are these devices and how they communicate? Second, risk and vulnerability management. So we've installed a device, or all the devices, we've understood how they interact, and then we need to understand which of those are using weak protocols or, again, based on the commands they issue, which problems they are experiencing, how to mitigate these risks without touching the main process. Continuous threat monitoring, response and threat intelligence. That's the analysis of what's happening based on the compromission indicators. Because we see how different components interact, we can detect outliers or deviations from the normal interaction and get the experts involved. And just like here at the standoff, we can see it happening. Operational efficiency, how to find the root cause of incorrect operation or setup error in the equipment. We can analyze the information and find such things and highlight it on the administrator screen. And finally, the unified monitoring and security management between IT and OT. How to group IT-OT components, how to use the existing processes and tools to centralize IT-OT security in the SOC. From the point of view of both the interest for the attackers and in terms of potential risks and threats, these are perhaps the highest value assets. And finally, how to show the auditors that our environment meets the safety and security requirements. If we break down the Azure Defender for IoT functionality, if we consider it, if we map it against the NIST domains, we see that it operates in all the 5 domains of the framework. That's identification, forestalling, detection, response, and recovery. So prevention includes automated threat modeling in OT networks, threat management and risk mitigation, again in OT networks, embedded integration with firewalls and NACs. The detection includes continuous OT monitoring. Response will include the tools for deep forensics and threat hunting, native connectors to integrate with CM, and integration with IT service management and security orchestration tools. Whereas a recovery is about creating reports and notification about errors in backup. If in traditional networks, user behavior analytics has been known for several years now, whereas the complication has largely been that the main counterpart interactions is a human. That is very hard to predict. In M2M networks, that OT networks are, here we're dealing with much less uncertainty, so it's much easier to collect the baselines. Coming back to a response, there are tools for deep forensic and threat hunting, native connectors to integrate with CM, to manage alerts as a part of unified management. And finally, integration with ITSM and SOAR environments allows you not only to get the alerts, but also to embed these notifications in ITSM processes properly. Now, the recovery domain includes automated report creation that allows understanding the baseline and come back to it, and also the backup error notification allows you to get rid of problems related to the information about readiness for recovery. The solution has been tested on the most sophisticated, complex environments in the world. Firstly, of Microsoft as such, I mean Microsoft Azure data centers. So there was a need to protect IoT devices. We understand that disruptions in the operation of such system potentially bring about the SLA not to be complied with and huge losses. So for us at Microsoft, it was quite a challenging project, but through direct integration with Sentinel, it was easy to integrate the solution with our Security Operations Center. And on the whole, I may surmise that the perfect experience of implementing this solution in-house has actually laid the foundation for this deal. Also, CyberX had customers from the Fortune 500 list in almost every industry, and in almost all published success scenarios, they mentioned the requirements that made the customers happy. That's quick implementation time and quick time to understanding of what's happening in the environment that used to be unmanageable. And the second thing is about speed and simplicity of integration with the security management systems using inbuilt connectors to CM systems and ITSM systems. Let's now take a look at the architecture of this solution. So we are proceeding from the fact, from the Purdue model, that splits operational networks in 5 levels. Field control, the sensors that are installed in the physical environment. That's process controllers that manage these sensors. Then engineering stations and monitors that aggregate this information, providing an interface to the centralized management system. And then you get the interface to the IT model. In this perspective, CyberX sensors, their location is between levels 3 and 2 and 2 and 1. There are different deployment options. You can deploy on premises. It's the easiest, traditional, and easily understandable option where everything is installed within the organization. There's a hybrid approach where sensors are managed locally in terms of settings and central administration, but they said they're connected to a cloud-based CM system, for instance, Azure Sentinel, and the model that is experiencing the fastest growth is the cloud model, where the sensors within the perimeter are being managed by Azure Security Center and are connected to Azure Sentinel. This being said, all logic and most functionality is provided by the sensor on premises as such. But configuration management and reporting is done in the cloud. And it's not only. The architecture allows fast deployment without adversely affecting the performance. Why? As I've already mentioned, we're not allowed to get into the network and the devices. So the mirroring approach through network traffic analytics or NTA, again, turns out to be a good way to collect the information from the network without interfering in its operation. The sensors are the devices that are certified to just collect the data. In one of the booths at the standoff, there's an example of how these devices can be used. The deep packet inspection technology with the patented analysis systems is used to analyze the behavior of the operational environment. The notifications are generated there, and then they can land either on premises or be sent to a cloud, including being passed to external systems. So, if we are to discuss whether the solution is located in the Microsoft portfolio, it falls within the standard Azure Defender portfolio, which, together with other technologies, is intended to protect the database, the operating system, the application, and network traffic. It includes alert response automation features. As to the advantages of Sentinel, apart from the standard advantage of Cloud CM, we can mention the machine learning based threat analytics based on trillions of signals. Again, transparency of IT and OT processes, scalability of cloud services. They can be scaled as high as you require. Additional advantages include access to detailed information considering the OT context from Azure Defender for IoT. It includes research specific from research by the Section 52, team-specific for OT threats. And so are scenario specific for OT. So it allows us both using the reference model and processes that can provide for this work as a foundation. Let's take a look at how this looks in terms of the UI. When you access the Sensor Console web version, it offers you a dashboard like this, where you can see information about alerts that have not yet been taken care of, about the threats identified, so that you could focus on them in the first place. As I said, the map automatically puts together an asset map, so based on the traffic, it classifies it by the protocol types, networks, VLANs, and device types. You can drill down the device where it's possible, so you don't only get the basic information about the model type and MAC address, but just like with this particular PLC from Siemens, you can get the information about slot utilization and the elements installed in those slots. And we also get access to control commands. One of the strengths that the user of the solution that the users mention is about the deep understanding of network-specific protocols. So in this connection, it's not a unified set of commands, but also the understanding of the content of the intent, allowing us to build comprehensive understanding of the assets that we have under control. The highlighted assets can be authorized or deauthorized. We can mark them as important, and then we'll be prioritizing their use. Or you can build a report based on their utilization. Apart from visualization, there's asset control, asset inventory, that can be quite useful when enriching this information with information from other systems. We can also export the list of the CSV file. So those assets, verifying them against the CSV file. So those assets that have not been reconciled, we will be marked as identified. The alerts are responsible for the operation of the engines, each being responsible for a specific area. Protocol violation, the packet structure of field values don't comply with the protocol specification. They said, I mentioned earlier that quite often the protocols are proprietary or just in-house developed by the customer themselves. So we can't cover the uncoverable. So in order to resolve the situation, an SDK has been developed that will allow the customer to develop their own protocol description in an easy way, upload in the system, and use it to process the information. As to then it was policy violation, malware anomalies, and operational issues, starting from the monitoring of outlier information. So, or for instance, when the code returns the wrong code, all these things can be processed and become the basis for alert generation. Alerts are classified in terms of importance and types, and also if you drill down, we get detailed information on compromission indicators, its components of this alert, so based on what it has been built, what assets were involved, and also we can use the information about how the system responded and how you could respond to this alert. At the top, as you may see, there are additional features such as generate a report, to make a snapshot of traffic within a specific time period, so that one could investigate deeper and in more details what has happened. In addition to the alerts table, there's an event timeline. So all the events that have happened are being connected into a graphic event ribbon where you can track the dynamic of the environment. There are certain alerts that can be tied together as part of the same thread. And so as a result, you can easily and quickly build the understanding, form an understanding of the situation. Apart from the analysis, we have reports, ready-made templates. Also, you can put together your own report based on the fields that are of interest to you, both in terms of behavior and in terms of protocols and commands being used as part of them. Also, there's this investigation panel containing widgets within which you can put together a graphic representation of the information that is important for you, like charts, pie diagrams, anything to form a quick understanding of what's happening in the system. And finally, the attack vector simulation tool. So based on the knowledge of how the joint components operate and what vulnerabilities they have, the system can simulate the passing from one segment to another for our most valuable assets. So we specify the source, we specify the destination, and then the system puts together the possible attack method or vector themselves, and also provides recommendation as to what needs to be done to close those vectors. Another thing, the risk assessment report. So again, based on all the information that we have generated during the audit, we can build a report, quite a nice, stable document that will, firstly, describe the level of security of the system. The concept is security score, a synthetic metric that we use to assess the security within the range from absolutely problem-free to an environment where all recommendations have been broken. So we collect this information as a basis. Also as a basic description and also as in the form of an executive summary with all the details sections below it. Again, detailed information is stored, including the recommendations, the mitigation recommendations. Also, we see how certain changes in each aspect will improve the overall security level. And to wind up, regarding the experience of using it at the standoff. Actually, it was quite an off-the-cuff adventure. On the eve of the freeze time, the team and I, the Inform Защита team and us, we decided to try and deploy the monitoring system for the ICS system, because the organizers do not allow somehow affecting its operation, which meets the real-life environment. Passive monitoring turned out to be the only solution that would allow to get at least some visibility without affecting the environment as such. So we managed to do it over an evening. So the delays were caused by the architecture, network architecture not being absolutely standard. On the other hand, as it has turned out, the preset functionality was available in the sensor. So the only problem was to find a person who would know how to work with it. So what did we achieve? So we automatically run the inventory control of the ICS segment and its components. We could see all the components and their capabilities. The solution became eyes and ears of the ICS team, whereas the integration of Sentinel provided for the notification transfer to the unified console. You have to understand that not a lot of data was involved in this story. But nevertheless, the speed and accuracy with which the protocols and commands were identified and baseline was formed were mentioned by the defenders separately. You can see how it looked in Azure Sentinel. You see how port scans and unauthorized external connections to the network, they were all being detected quite fast and with a good accuracy. Winding up, I would like, what I'd like to leave with you is the understanding that the protection of operational networks requires specialized tools. And Azure Defender for IoT is exactly a tool like that, providing intelligent monitoring and OT, IoT threat assessment. The solutions architecture allows using it completely standalone, and also in integration with the centralized security incident management system based on Azure Sentinel. The solution can be used absolutely standalone, providing for the management of the system itself and its components over the air gap. So that brings me to the end of my presentation. Thank you, Kirill. Let me remind you that that was a Microsoft information security solution expert, Kirill Bogdanov. Thank you all for the attention. We'll be back after a short break.